Okay, so good morning. Here in today's session, we are going to discuss about one of the important concept, elastic load balance. Okay, so in this elastic load balancing, what's the use of going for this elastic load balancing? So this is one of the real-time scenario that we are making use of for load balancing across multiple nodes. So assume you have one system with one microprocessor and 1 GB of RAM. Let me imagine this as a web server, which is serving some contents. Okay. So with this hardware, it is assumed that it supports 1,000 user requests. Okay, at a particular time. So on a given time, it supports 1,000 user requests with the above set hardware. So assume that if the number of user requests increases to plus or minus 10%, for example, if it is 1,100 requests, then this web server can able to tackle the request with a little bit degraded efficiency. But what happens here in this case? If the number of requests increases to 2,000 or 1,500 or 1,600, so the web server couldn't able to it can able to handle only 1,000 requests. If it is plus or minus 50% increase, then in this case the web server couldn't able to handle this much of increased load. And what happens to these cases? Here it will get caught with panic, so it will down. Therefore, to overcome from that, what we need to go for? There are two options. Either you can add the resources, you can add additional CPU and additional RAM memory, or with the existing system itself. Okay, to the existing system, you can add one microprocessor, additional one microprocessor plus one microprocessor and 1 GB of RAM memory. Else what you can do, option 2, you can add an additional server with the same configuration, one microprocessor and 1 GB of RAM. Okay, the web server need to configure the same services associated with your server. Now you have two servers, so each server can able to handle 1,000 requests at a time. Therefore, the user request want to be redirected evenly across these two servers. So for that we need to configure the CLB. This is called as elastic load balance. If the number of requests increases further, you no need to worry about. You can add another server, web server 3, and all the server will have the same content. And the elastic load balance, what it will do, it will redirect the user request across all these three servers. By the way, the loads will be evenly distributed across these three servers. Here, the process of automating this activity here can be done in Amazon by using a service called as auto scaling. What we are performing here, we are scaling the resources. We are performing the action of scaling. In terms of scaling has been concerned, there are two types of scaling. One is vertical scaling and second one is horizontal scaling. So vertical scaling in sense, so here you have one server and the server itself, if a server is lagging in resources, you add additional resources with the same server. That is called as vertical scaling. Here in ELB, we are not going to perform a vertical scaling. Here we are going to perform a horizontal scaling. Here we have a server. So if the server is suffering from overload, then we add additional server of the above set configuration. So we can go and add the server in this manner. This is called as horizontal scaling. Okay, so what is the function of load balancer? In this sense, load balancer will distribute the incoming traffic to the server across these multiple instances. So here in this example, we have started with this single server. As the load increases, we have added additional server. As the further increases, we add additional server. The load balancer it will serve as a single point of contact. All the clients requests first come to this elastic load balancer. And the load balancer, what it will do? It will redirect the request, okay, to all the associated servers in a evenly distributed manner. Okay. So here we no need to worry about the incoming traffic if we have configured this elastic load balancer. Also, apart from that load balancing, what it can do is it will monitor the healthy states of the instance. Which instance is the healthy one? Which instance is failed? Like it will monitor the status of the instance. That is, it will maintain the health checks. then the health check will be maintained by the TLB for every 3 seconds. So we can configure this configurable parameter. We can configure this health check. Okay, it will monitor the instance, and if it found that the instance is in unhealthy state, yes, we need to configure additional service. So here we need to configure a separate ELB. In our practical, I am going to show you how to configure ELB. Here, so this instance will be monitored by ELC. So it will work with about whether the instance is healthy or unhealthy. If the instance is found to be unhealthy instance, elastic load balancer, what it will do? It will simply mark the instance as unhealthy, and what it will do? It won't send the traffic to the unhealthy instance. In this case, if the instance is unhealthy, and we have only assumed that in this further example, we have 3,000 requests. All these 3,000 requests has been distributed across these 3 web servers. And once one web server gets down, what happened here in this case? Now these 3,000 requests need to be distributed only with the healthy instance, 2 instances. And once again, the instance will get caught with panic because beyond its capacity of 1,000, we have 1,500 requests need to be serviced by these 2 web servers. It may get caught with panic. So the elastic load balancer need to add additional instance. Okay. In this sense, if we can configure auto scaling to this elastic load balancer, we can automate this activity. So auto scaling instance, we can perform the scale up or scale down activity. What is the scale up? Adding the new instance. Adding an instance is called as the scale up. What is the scale down? If you feel that now you assume that you have 3 web servers which can able to tackle 3,000 user requests. If the number of user requests down to 700, in this case, how many web server is enough? 1 web server is enough to tackle these 700 requests. In these circumstances, if you have 3 web servers, you know you need to pay for these 3 web servers. To overcome from these sort of things, what you can do? So you can release the underutilized 2 web servers. This process of releasing the underutilized web server, that is, adding an instance is called as a scaler. Releasing the underutilized instance, that is, releasing an ideal instance is called as a scale down. This activity can be automated by using a feature called as auto scaling. In reality, this elastic load balancer will be integrated with auto scaling. Okay, you have the following integration. You have elastic load balancer integrated with this auto scaling feature, and whenever we make a scale up or scale down, okay, whenever you add the instance or you remove the instance, this need to be notified. Both adding or removing need to be notified to the administrator. So then we need another service. In order to send the notification, we make use of this SMS, simple notification services. So how you can add or remove an instance? So for that, what you need to monitor the server. For example, you are configured this elastic load balancer. Imagine a web server. So how you can make this adding or removing possible? You need a monitoring service. You need to monitor the resource. Okay, the CPU, the RAM capacity, the hard disk capacity, number of incoming requests, number of network packets in. So for that, you need to have a monitoring. Based upon this monitoring statistics only, you can able to find out whether this instance which is running here is suffering or from additional workload, or the instance is found to be idle. So for that, what we need to add another service called as CloudWatch, which is a monitoring service. So in a real environment, we have this elastic load balancer, auto scaling, CloudWatch, and SNS, all the 4 integrated in a real environment. We have already discussed about this CloudWatch, I think so. Simple notification service in our last session. Sadiq, whether we have discussed, we attended the session of SMS, how to set a notification. Please, can you send me yes or no? No. Okay. Now we will discuss that notification also. No issue. We have already discussed, I think so, in our previous class. As you are found to be absent there. Now let me start this discussion on elastic load balancer. Okay, so here in Amazon, the elastic load balancer, we have two types of elastic load balancer in AWS. One is for application load balancer, and another one a classic load balancer. Okay, so according to your requirement, you need to go for using either a classic load balancer or using an application load balancer. So the application load balancer is the current load balancer. The classic load balancer was the initially created load balancer. Okay, according to your requirement, you can go up with the protocols supported for application load balancers. For web server, we need to go for application load balancer, HTTP, HTTPS like thing. Okay, here it will work with the default VPC, virtual private cloud, or you can create your own VPC. This is the older version. The classic load balancer will the older version. It also supports this HTTP secure. Also, it supports some secure SSL and TCP protocol. Okay. Apart from this, if you are going to configure a mail server under this elastic load balancer, you need to go with this classic load balancer for configuring a mail server, for configuring a DHCP server like thing, which needs this TCP protocol shoes. If you are going to configure application, like you are going to configure a web server, which is hosting some applications on top of it, then you need to go for this application load balancer. So these are all the major differences associated with application load balancer and classic load balancer. We are going to do a practice with respect to this application load balancer. Okay. So here, how you can access the load balancer? You can able to access this load balancer using 4 ways. One, by using this console mode, what we did so far, the console mode of access. Also, you can make use of another mode called as CLI mode, which we are going to discuss on coming Tuesday morning. Command line mode, how to configure AWS command line interface and how to make use of those commands. Okay, and third mode, we can make use of this software development kits associated with the APIs, application programming interfaces. So if you are a developer, the developer can make use of this SDK with the API, application programming interface. You may make use of a language like Java, Python, Perl. So these are all the most widely used languages for each and every language. So we have these resources. Amazon Web Service, the resources will be that. We have EC2, we have S3, we have ELB. So here the user can write a program, either a Java program or he can use a Python program. So for each and every program, Amazon is having APIs. Okay, they are having a REST API. So through this API, nothing but application programming interface, which provides the interface between the user written program and AWS services. So how to access the service, how to start the service, how to stop the service, everything will be given under methods and classes under the API. The user want to know which method needs to be invoked for a particular action. So using the opposite languages, we can able to have an interaction. Our discussion being the course is being associated with the solution architect and administrator. We are least bothered about how to interact using API and SDKs. Our discussion will be based upon to make access to the opposite services using a console-based access and a CLI-based access. Okay, so these are all the things associated with. So elastic load balancer can associate with the opposite service, auto scaling, CloudWatch, simple notification services. Also, if we are going to work with Docker, here we can make use of another service, ECS. Okay. So on Docker, we will have a discussion of Docker, which is nothing but the advancement of virtualization. Okay, a lightweight container component which is going to replace the virtualization. So if you are going to work with this virtualization, the Docker in Amazon, you need to make use of a service called as ECS. Okay, Elastic Compute Service. You need to go for this ECS. Docker service, ECS stands for Elastic Container Service. EC2 stands for Elastic Compute Service. What we are so far discussing is EC2. This is container service. Okay, the service associated with the Docker. You can also integrate ELB with this Docker also. So in this case, if you are having a web server, In this case, if you want to configure the domain name in your own domain, if you launch your own domain in Amazon web server, then in this case you can also integrate another service called the Route 53, which is a DNS service. So these are all the services that we can able to associate with your ELB. Now in our use case, we are going to associate ELB with auto scaling, CloudWatch, and notification services. We are not going to associate with this ECS. Why so? Because ECS is a separate entity. If and only if you know the concept of Docker, then you can work with ECS. Laterally we can do. So this is the way by which you are going to associate your elastic load balancer. Now you know what is elastic load balancer. Okay, and then associated activity associated with this elastic load balancer. Then what we need to configure with this elastic load balancer? No, we cannot create our own domain for free of cost. If you are going for creating a domain, as of a normal domain, you need to pay for. I will let you know how to associate the domain by getting a free domain. Okay. Now, the working principle of elastic load balancer. How the elastic load balancer works. In this scenario, what we are going to do here is, I am going to create two web servers. Okay, web server 1 using a Amazon Linux. Step 1, I am going to create two web servers. Those web server operating system is Amazon Linux. You can make use of any operating system. Next, step 2, I am going to create a ELB, elastic load balancer, and while creating a elastic load balancer, I am going to attach the above two web servers into it. And I will receive user request to this ELB, and ELB will distribute the request equally across these two servers, web server 1 and web server 2, that we will simulate. So we will simulate multiple user requests so that the user request will be go forth and back to the both web server 1 and web server 2 will be showcased to you. This is the thing that we are going to make use of. So what we are going to do, we are going to launch this instance not on a single availability zone, in multiple availability zones. Also because the reason behind going for this web server elastic load balancer is high availability. If you launch, this is mandatory that you need to launch one web server in one availability zone 1, another web server in another availability zone. Also because if you launch both the web server 1 and web server 2 to the same availability zone, it may, if the availability zone gets crashed, then it may result in a problem. You can't able to access the data even though you have two servers. So for that reason, here it is recommended to work with the multiple availability zone. Okay, so this is the concept behind this particular use case. Here the elastic load balancer, it also monitors the health of the registered instance. Okay, so here we have attaching instance. We are registering the instance with ELB. We need to register the instance with ELB. Simply, if you create the instance and if you create the ELB without registering the instance into ELB instance, you can't do any activity. So once the instance has been registered, the load balancer will monitor the health of the instance. Okay, it will check whether the instance is healthy or not. So if a load balancer finds the instance is a unhealthy instance, what happens immediately? It stops routing the traffic to the instance. It won't send the traffic to the instance, and then here it will send the traffic only to the healthy instance. So in this case, each and every instance, what happens? It will have multiple listeners. Okay. So it will have, the load balancer will have multiple listeners. So here you have this ELB. ELB will be having multiple listeners. The listeners Okay, the listener is nothing but a background process. It is checking for incoming connection request. Okay, so this listener contains the port number. Through this port number, it will receive the request from the client. The multiple client will send a request, and the ELP's listener will receive the request, and the listener what it will do. So it will redirect the corresponding request to appropriate web server in a evenly distributed manner. Okay, this is the working principle of this elastic load balancer. So if you have any doubt, please let me know before proceeding further. Okay, now we are going to create a load balancer and do the practicals. So this is the sequence of steps that you are going to perform. First, step 1, create 2 web servers. Then after creating, create a application load balance. Create a application load balance. Then after creation, you want to configure the load balancer. And you want to configure a listener. Why so? Because the listener alone will get the request from user. Then you need to configure a security group for your load balancer. The security group to access it need to have the following incoming rules. It should allow access to SSK. Being we are going to configure web server, it need to have a access permission for this HTTP and HTTP also. Next, you are going to configure a target group. You are going to create a target group. So this target group, after creation of the target group, you are going to attach, we call this register, the instance, that is in this case the web server 1 and web server 2 to this target group. You want to register the instances into the target group, and everything is perfect, you create a load balance. Okay, so first you are configuring a load balancer. This process is configuring a load balancer and listener, and you at the time of configuration you need to configure a security group for your load balancer, and then the security group need to be incorporated with the following thing. It should have access to SSK and it should have access to HTTP. Okay, these are all the sequence of process that we are going to do. So the prerequisites. So before going into that, you want to choose the availability. What are all the prerequisites? Before configuring your elastic load balancer, first you want to choose the VPC. Either you are going up with the default VPC or you are going to create your own VPC, own virtual private cloud. That is the first thing that you need to have. So here this VPC need to have, if you are going to configure application load balancer, by default, the default VPC will have a, we need to create a subnet here in this case. You can create either a public subnet can be designated as a public subnet or a private subnet. Okay. So the prerequisites for configuring application load balancer is you should have at least one public subnet. That is the main thing. So you should have at least one public subnet. Here in this public subnet only you can able to launch your web server. That is the first thing. So by default, the default VPC by default it will have a public subnet. So the thing that we are discussing is specific to if you create your own VPC. Okay, so these are all the prerequisites. Then the public subnet, if you launch it in a private subnet, then you can't be able to connect this web server from the external environment. Okay, these are all the things that you should make a note of. So before going up with this load balancer. Okay, now let me do the practical part. Let I connect to this Amazon. I am going to connect with my Amazon www.aws.amazon.com. Sign in management console. So let I create an instance. Click on EC2. I am going to do the step 1. I am going to create 2 web servers. Launch instance. Let I choose Amazon Linux. Okay. So configure instance detail. Yes. Okay. Number of instances. I am going to launch 2 instances. 2. So I am not going to choose my own VPC. So in this case only I need to follow this procedure. If I go up with this my own VPC, that is own VPC, it should have a public subnet. So if I choose this default, by default it will have a public subnet, so you no need to bother about that. I am going to choose this default VPC alone, not my own VPC. Since I yet to create any VPC here, I am choosing a default VPC. So here I am going to launch this instance. Okay, next add storage, 8 GB is enough, add tags, then we add a tag, web server 1, WS1 and WS2. Okay, so let me give a name WS1. Similarly, name WS2. Next we configure security group. As I told, you have to have the security group containing both HTTP and HTTPS. You should have HTTP port number, access from anywhere. Similarly, you can also have a secure HTTP secure. Yes, save the rule. Launch. Now you need to choose a key. Here the key that I am choosing is I have already having a key. I choose the key. Let I choose which key that currently I am having. Okay, please wait out. Mala 6. Okay. Acknowledge and launch instance. Now I am having 2 instances. Let I make one instance as web server 1, another instance as web server 2. Now I need to configure a web server to this instance. Okay, it is an instance with Amazon Linux. I am going to configure this. Okay, for that let I create a notepad. Let I make use of a notepad. HTML body bg colors equal to green, header 1, web server 1, header 1, close the tag, close the body tag, close the a simple HTML page. Okay, So web server 1. Similarly, we can also have another copy, Control V. So we have web server 2. So for green, let me make it with blue to differentiate. Now we have 2 pages. Let me now connect to web server 1. Okay. Let I connect to this web server. Copy, connect using putty, paste. So it is not a web server, it is an instance. I am going to configure a web server on top of it. Browse. The default user is EC2-users here. Now it got connected. So what I need to do, first I am going to make an update. Sudo yum update. Yes. First let I install a web server, sudo su. Okay, let I install yum install httpd. httpd. Yes. We have already discussed about how to configure a web server. I am installing Apache web server httpd. Okay. If it is Ubuntu, I need to configure Apache 2. So sudo apt-get install Apache 2. Here being it is Amazon Linux, you need to install using yum install httpd. So after that you can get a service. Service name httpd, you can get the status of the service. Now you can find HTTP is stopped. What you need to do? You want to start the service. So before that, let me add a web server content. Okay, where to add a web server? By default, you need to add a web server under the following location. Under where www, there will be HTML. Okay, so in this instance, under this location where www, you have a HTML. Under HTML, you want to create a page called as index.html. Okay, this is the default location. When you configure a machine as a web server, here you want to paste this HTML script, what we have created here. Okay, we have created a HTML script. The script needs to be pasted here under the following location. Okay, where www.html. Move to the location. Now present working directory, you will be under home EC2 user. You move to the location cd/var. Here if you find, you can find here under where you find this www. Okay, here you can find the www. cd www is the location. Here you can find a HTML here. cd HTML. Here you need to create a index.html page. Okay. So let I create an index.html page. Okay, va index.html. This is the page where you need to host this web server. Insert. You simply copy this HTML bg color. Okay. Right click. Copy. Come to the location. Paste. A simple web server which is displaying web server 1 with green color. Escape :wq. Now it is working. Okay, index.html has been created. Now you need to start the service. Since the service status is stopped, service name, status, httpd status will let you know the status of the service. It is stopped. Service name, start is the way by which you can start the services. T-A-R-T, start. The service got started. Now if you check the status of the service, it is in a running state. Now you have configured this as a web server. Therefore, if you type this URL on a web browser, it will result in a new web server. Okay, it will display the page that is listed on index.html. Open, copy, create a new URL, simply paste. Now you can find. A network change is detected. What is the problem associated? You can check with the inbound rule. Okay, let me check with the inbound rule. Yes, it is now working. Web server 1. So this is the way by which you configure a web server. Okay, now let me configure the additional thing, the second machine. You have configured web server 1. So before configuring this machine as a web server, let me check. Just we have installed only operating system alone. Copy. Let me open another URL. If you simply paste the URL, it won't display anything. Which is because it is not a web server. So let me configure this as a web server. Okay. Web server 2. Let me connect. Copy. Paste. SSH. Authentication. Okay. Authenticate. Open. Open. To create another machine. Yes. You are connecting to another second machine. EC2-user. So once again, you are going to make a sudo m update. Sudo m update. Yes. So next, you are going to configure this as a web server. So here the command that you need to configure for a web server is, you need to install this HTTP. Okay. So yum install HTTPD is the command that you need to go for. Yum install HTTPD. Yes. So you want to, now you can check the service HTTPD status. You can find HTTP is stopped. You need to start the service. Before that, let me open a VI under where we have www, we have HTML. Let me create a index.html page. Okay. Let me insert the web server 2. We have in our web server 1 highlighted a green color. Here we can highlight a blue color to differentiate. Copy. Connect with this. Simply paste. Escape :WQ. Yes. Now you have this machine configured as a web server. Let me start the service. Service HTTPD start. Now the service got started. Then if you load this in a new URL, it will display the corresponding web page. Okay. Let me connect with this and let me open this URL. Click on copy. Now this is the URL that we made. If you simply enter, it will show you a web server 2. Yes, you have web server 1 and web server 2. So first you have configured 2 web servers. Okay. Step 1 has been over. We have created 2 web servers. Next, what we need to do? You need to configure a application elastic load balancer. You want to configure a listener. Listener will listen, being it is a web server. Which port that you need to configure for this listener? For this listener, you need to configure the port number 80 HTTP, and you can also configure this HTTPS port. So the listener will listen the user request through this following two ports. Whenever the request comes, the listener will receive the request and it will forward the request to the appropriate web server that you have attached with this Elastic Load Balancer. We are going to do this second activity. Okay, let me create a load balancer. Now we have created these two web servers to be got attached to the load balancer. Now let me create a load balancer here. Move on to the lower end where we have this load balancer and target groups. Okay, click on load balancer. Click on load balancer. Click create load balancer. Now you have two types of load balancer, a classic load balancer and application load balancer. Okay, we are going to choose with the application load balancer default. Continue. Now you want to assign a load balancer name. Let me make it as Sadiq. Load balancer name as Sadiq. Then there are two ways by which you can configure either an internet facing or an internal load balancer. So since we are going to get the user request, you need to choose this option internet facing, where you need to go for internal load balancer. If you have a database server, imagine if you have a database server under which if you need to configure a load balancer which distributes the load across your database server, you need to configure a internal load balancer. This is the scenario. I will share you the scenario. Now we have configured web server 1, web server 2, under which these two web server 1 and web server 2 we have configured a ELB. Through this ELB, any user from internet should make a connection with the web server. So here there may be one situation. Internally you need to configure a database server. Database server 1, database server 2, DB server 1, DB server 2. So user, you should have a ELB which distributes the load across these two database servers. Let me consider the concept of rack. If you go for this distributed real application cluster, under which user requests one server, a primary server, another one a stand-based server, okay. So this is the way by which these two servers should not be made accessible from internet. So in this sense, what you can do, you can here at the front end create a web server and you create two load balancers. One is this load balancer is a public web load balancer, internet facing load balancer. So this is a private load balancer, the internal load balancer. Okay, so you can configure this load balancer as a private, so internal load balancer. And whenever the user request is received, the ELB will forward the request to the corresponding web server, and this web server can store the data through this ELB under this database. This is the scenario under which the database server, being it should be denied for public access, we need to configure. If you are going up with this sort of thing, we need to choose this internal option, which is the private. Then if you are going to receive the user request from public, then you need to choose internet facing. These are all the scenarios. So we will have this use case while we are discussing with the VPC. We will discuss this use case. I will let you know how to configure. Let me configure two subnet here in VPC. One subnet as a public subnet, and we will be launching web server here. And let me create another subnet as a private subnet and launch database server, and we can make a connection between a public and private subnet. Therefore, any user can able to access only the web server. Internally, the web server may have a connection with database server. We will do this practice while discussing this VPCR. Okay, a real scenario. So now we choose, being we are going to allow the user from internet access, the option that you need to choose for this scheme is internet facing. You choose option 1, internet facing. Okay, so the type of IP address, being it is IP version 4, you can make use of it. So next, you want to choose this availability zone. So since you are currently working with a particular North Virginia, you can choose any two availability zone. Availability zone 1A, 1B, 1C. Okay. North Virginia is having 6 availability zones. You can choose any availability zone. If you want to tag, you can assign a tag. Okay, you can assign a tag name Sadiq. It is an optional charge. Next, configure security group. Okay, select the existing security group. Your security group for your load balancer should allow which thing? It should allow this HTTP and HTTP access. So probably, I think so, your instance may have a following access. Let me choose Launch Wizard 7. Configure routing. Okay, you want to specify a new target group. Okay, new target group. You give the name of the group. Sadiq is the name of the group. The protocol that is going to, this is the listener. You are configuring a listener. HTTP, it is a web server. You are going to configure HTTP. It listens in port number 80. Okay, so register targets. So now the target is empty. You can find the target is empty. No instances is found with the target. Here you are 2 instances running with the security group Launch Wizard 10. What you can do? So you can attach this web server and you can register the web server to this target. Let me choose this web server. Choose this web server and then add to register. Now we can find these 2 web server has been registered with this target group. One web server is in US East 1D. Okay, these 2 web server another in US East. It is optional. You can choose anything. The security group attached this Launch Wizard 10. Okay, click, choose. These are all the 2 instances. Next review. You can find the load balancer name as a Sadiq and the scheme is internet paging. It is listening at the port number 80. It supports IP address version 4, which is launched in default VPC under the following subnets. Okay, so these are all this threshold. I will let you know what is healthy threshold, unhealthy threshold, timeout and intervals and so on. Let me create a load balancer. Load balancer start created. Now we can find it created. It is attached with the target group and it is successfully created a load balancer. Okay, now we can find go to service, EC2 service. You can check whether your load balancer is created or not. Click on instance. You can find these 2 instances, web server and web server 2 attached to the load balancer. Click on the load balancer. You may find a load balancer here. A Sadiq. You can find the details regarding to this load balancer. You have name of the load balancer, the resource name here. This is the DNS name assigned to this load balancer. Okay, this load balancer will be running on the following availability zones. Okay, if you go and click on listener, you can find the listener port number 80 is attached to the load balancer. Okay. This is the rule of your listener. Okay, you don't need to worry about that. So if you want to check whether everything is working fine, your the instances, the underlying web server is attached or not, you need to look into the target group. It is a little bit slow. Click on this target group. You can find the target group. Again, the name of the target group that we have attached to the load balancer is Sadiq. You can find the targets. Now you can find 2 targets. Okay, 2 targets whose status is unused. It need to be live. You wait some time. The 2 targets need to come to the status. Now it is in unused status. Now you want to move to the status working status. Let me wait for a while. Let me wait. Okay, the target need to be registered. Monitoring. The instance yet to attach with the target. So the target need to process the health check. Okay, then only you can able to access. Now let me check whether it is working. Sorting. So you want to choose this DNS name, copy, open a browser, paste, enter. So my machine is little bit slow. Okay, you go to, before that you go to security group. I think so launch wizard 7. You need to attach the inbound rule. Okay, edit, add a rule, attach a HTTP. I think so we have chosen HTTP from anywhere, here too from anywhere, another rule HTTP. Yes, if it is not mandatory, it is an optional thing for your web server, you need to make it save. Similarly, we have this launch wizard 10. So we have everything has been saved here. HTTP, HTTPS. We have already attached this to. Okay. We need some time for this instance to register. Yeah, the problem may be with the same. Okay, so no issue. Here the state initially we committed something. I think so. What is the error we have committed? Now the status is in initial state. It is registering with the target. Once it is registered, the state will become an active state. So until we want to wait. Until the state become active, we want to wait. being my network is slow, it took some time. Now we can find the status of target found to be healthy, and we have both the two target is in healthy state. Okay. So the health check will be done on using the following parameters. Okay. It will check the health of the instance for every 5 seconds once. If continuously, if for 25 seconds the instance was in healthy threshold, then it will take it as a healthy. If to attempt a number of consecutive health checks, in this case, if it is failed continuously for 2 times, the instance will be considered as an unhealthy instance. Okay, so this is the interval. 30 seconds once it will check. It will request a response for every once it invoke a healthy or unhealthy request. It will wait for 5 seconds. Before 5 seconds, if a response is not received, then that is treated as an unhealthy output. Okay. So if it is a success, the success code is 200. If you receive any other code, then it is a failed code. Okay. Now we can check whether the instance is working fine or not. We got targeted. Now we have this load balancer. Click on this load balancer. Select the load balancer. You choose this DNS name. Okay. By default, we have two server 1 and server 2 configured. First, the load need to be. We have already having server 1 and server 2. Then open a new URL and paste the URL. Now it will take me to any one of the server. Now it is web server 1. Okay. So if I inject the request, I need to make a continuous refresh. Now you can find it is moving back web server. I am pressing F5 here. Now my request is web server 1. If I press continuously F5, all the subsequent requests will be redirected to web server 1 and web server 2 in this manner. This is the way by which you need to configure your web server. This is web server 1. This is web server 2. Now this is the Elastic Load Balancer URL. You can find the name of the URL through. It is connected with web server 1. If I simply inject my request by simply pressing F5, at one point of time we can find the 1 2 1 2 1 2 will be go forth and back to 1 and 2. Okay, this is the way by which you need to configure your web server.